Section 3 of the National Geographic Magazine, Volume 4. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne Spiegel. Studies of Muir Glacier by Harry Fielding Reid. Part 1. Introduction and Narrative. A desire to see the Alaskan coast more thoroughly than is possible to ordinary tourists led to the formation of a party to spend the summer of 1890 encamped there. The description of the Muir Glacier by Professor Wright turned our attention to that point. Its accessibility and the interest awakened by its reported motion of 70 feet a day decided us to camp at its mouth and study the glacier and its neighborhood as thoroughly as time would permit. The first request was a reliable map of the region. None such existed, and we determined to devote much time to a survey and to make a map which would show with some accuracy the extent and form of the glacier and the positions of the mountains which surmount it, and also serve to determine what changes may take place in the future. We also planned a careful measure of the motion of the ice, a determination of the magnetic elements, a regular meteorological record, a study of the geology of the region, a collection of plants, and observations of all indications of change in the extent of the glacier, the amount of glacial erosion, etc. The party consisted of Mr. H. P. Cushing, who took charge of the meteorological records, the geologic observations, and the collection of plants; Messrs. H. McBride, R. L. Casement, J. F. Morse, C. A. Adams, and the writer. It gives me pleasure to acknowledge that it would have been impossible to accomplish the work if it had not been for the cheerful and efficient aid which all my companions rendered. Muir Glacier seems to have been known only to the Indians until 1879, when it was visited by Professor John Muir and Rev. Mr. Young, but they were prevented by bad weather from much exploration. In 1886 Professor G. F. Wright devoted a month to its study. We are indebted to him for a very interesting description. Until our visit, in 1890, these were the only attempts to obtain any accurate knowledge of the glacier. Glacier Bay offers the luxury of exploration. Visited weekly during the summer by steamers of the Pacific Coast Steamship Company, the explorer can take with him everything necessary to his comfort, can renew supplies when necessary, can receive and dispatch his mail, and still be in a region of which little is known, a region of great interest to the geologist and student of physical geography. It seems strange that it is not more thoroughly studied. On July 1st the George W. Elder cast anchor in Muir Inlet, not far from the glacier, and landed our instruments, tents, personal baggage, and provisions on the eastern shore. We found Professor Muir and Mr. Loomis encamped there. They had come also to study the glacier, and added much to the pleasure of our stay. We immediately set to work to put up our tents, and before evening everything was in good shape. We brought boards from Juneau for flooring, tables, etc., which added materially to our comfort and convenience. A bookshelf held our small library of works on glaciers, logarithmetic tables, etc. A gasoline stove enabled us to cook our meals with ease, and camp stools permitted us to eat them in comfort. This was to be our base camp, and in honor of Professor Muir we named it Camp Muir. Here we stayed until the middle of September, making various excursions of several days' duration to points too distant to be visited in one day, always, however, leaving two of our party at camp to make the meteorological observations. We had with us a rowboat 16 feet long, provided with a sail, and during our stay we bought from the Indians a small dugout canoe which would carry 3 persons. On one occasion, in company with Professor Muir, we rounded the western headland of Muir Inlet and pushed a mile or two up Glacier Bay. The water was so full of floating ice, in pieces large and small, that our progress was very slow, and we finally landed for the night, hoping to find clearer water the next day. In this we were disappointed, and therefore rowed back again and crossed the bay to the large island opposite Muir Inlet. It was in this limestone island that Mr. Cushing found the fossils which make it probable that these rocks are of Paleozoic age. Later in the evening we returned to Camp Muir. On another occasion, following Professor Muir's example, We made sleds on which we packed our blankets, provisions, and instruments, and spent 5 days exploring and mapping the eastern part of the glacier. We ascended Tree Mountain (2,700 feet) and Snow Dome (3,300 feet), which, though of moderate elevation, command excellent views. Another time we visited the stations marked S and T on the accompanying map (plate 14), and descended one of the peaks just to the westward. We also ascended Pyramid peak, approaching it by the valley of the dying glacier. The weather unfortunately was misty, so that we added little to our knowledge of the mountains toward the west, except to see that they were numerous and did not seem to surround any very large valleys like that occupied by Muir glacier. Shorter excursions were made on all clear days to points more easily accessible. Among these the most interesting were connected with the measure of the motion of the ice. To plant our flags where we wanted them required us to make a way among the crevasses, which offered great difficulties. Some experience in the Alps had taught me what means were necessary for progress in such places and what precautions should be taken to avoid accidents. We were always roped together, and we were provided with ice axes, which served to cut steps in places where we could not otherwise stand. Balancing on narrow ridges, creeping along steep walls, or crossing crevasses on pieces of ice that had fallen in and bridged them over, were the usual methods of progress. Our precautions, however, rendered accident impossible. When at Pyramid Harbor, in Lynn Canal, we engaged William York to go with us to help in camp work. At the end of the first month, finding the work too confining for him, he left us with our consent and made his way back to Pyramid Harbor, following the stream down Muir Valley to Lynn Canal. After his departure we did all the camp work ourselves. The officers of the steamships were very courteous to us. Captain Carroll brought us all the material, ready cut, to make a house with 2 windows and a door. It was put up during a rainy spell when we could not do any work away from camp. Indians, or as they were called in this region, Siwashes, had sealing camps at Glacier Bay, but only visited the inlet when the steamers brought tourists, with whom they carried on a lively trade. General Geography. The southeastern extremity of Alaska consists almost entirely of an archipelago, which occupies a space nearly 350 miles long and 100 miles wide. The islands, large and small, are closely packed together, and the waterways between them are deep and narrow and often form long, straight canals. The islands are mountains and precipitous, affording few landing places. Their slopes are densely wooded, mostly with spruce. The rough surveys of Vancouver 100 years ago, as revised later by Tebenkoff and others, were until 1867 largely relied on as supplying the most accurate information of parts of the coast. Since that year, the explorations and surveys made by the United States Coast and Geodetic Survey under the direction of Assistant Davidson, Acting Assistant Dahl, and, during the period from 1881 to the present time, by naval officers of the Navy attached to the same survey, have resulted in the publications of charts and other data making known the more important channels and waterways with ample accuracy for navigation. Southeast of the Alaska-British Columbia boundary the islands become larger and the waterways wider. Cross Sound and Icy Strait form the northwestern boundary of the archipelago. From them 2 deep inlets, Lynn Canal and Glacier Bay, stretch toward the north and northwest, forming, with the Pacific Ocean, 2 peninsulas. The great Fairweather group of mountains occupies the western part of the peninsula between Glacier Bay and the Pacific. The eastern part is occupied by another and much lower range, whose peaks rise about 5,000 or 6,000 feet above the sea. Their northeastern slopes are gradual and are covered with large glaciers, some of which reach tidewater and discharge icebergs into Glacier Bay. Between these 2 ranges there seems to be a deep valley which drains the eastern slopes of the Fairweather group. This is probably filled by a long narrow glacier discharging into Taylor or Dundas Bay. Little was known of the peninsula between Glacier Bay and Lynn Canal before our expedition mapped its northern part, except that it is entirely made up of glacier-bearing mountains, whose peaks are from 5,000 to 7,000 feet high. Northwest of Cross Sound the character of the coast changes abruptly. The coastline becomes continuous, without outlying islands, and broken by few inlets, and mountains of great height rise immediately from the water's edge. We can therefore, topographically, divide the southeastern coast of Alaska into two regions. The line between them passes along Cross sound, then follows the valley just northeast of the Fairweather range for 40 or 50 miles, beyond which point we know nothing whatever about it. This topographical difference seems to be accompanied by a geologic difference. Mr Russell has shown that the St Elias Alps are of Tertiary origin, and probably the Fairweather group belongs to the same range, though I believe it has not been explored. If this is true, the Fairweather mountains are of Tertiary origin, while the rocks forming the mountains about Muir glacier, and probably the rest of the same topographic region towards the southeast, belong to the Paleozoic and Anarchean. Another difference is quite marked. Mr Russell has found raised beaches about Yakutat bay, indicating that the land there has risen, whereas the submerged trees in Muir inlet show that this region is sinking. These striking facts seem to show that the valley between the Fairweather mountains and Glacier bay follows the line of an immense fault which brings Tertiary and Paleozoic rocks into close juxtaposition. It is most unfortunate that we have no observations on the Fairweather mountains that will enable us to confirm or correct this interesting indication. Glacier bay and Muir inlet. Glacier bay itself has not been surveyed. The delineation in the Coast Survey charts is correct only in its general outline. It trends northwest and southeast, and is about 40 miles long by 10 wide. There are a great many islands in the bay. The Beardsley Islands, which fill the eastern side for a distance of about 20 miles from its mouth, are made up, at any rate in part, of modified glacial till, and are generally thickly wooded, as are also the shores in the lower part of the bay. The channels between these islands are narrow, and often give one the impression of waterways cut through the land. The islands in the upper part of the bay are quite different. They are of solid rock, and are scored, polished, and rounded by glacial action. They occur singly, are usually elongated, and have a longer axis, parallel to the nearest shore. They, like the mainland, descend abruptly into the water, and only at long intervals can even a small beach be found. In this part there are no trees. Several glaciers force their way down to the water level and discharge bergs into the bay. Most of them end in narrow inlets 2 or 3 miles back from the bay proper. Muir glacier is of this type. Its inlet, which runs nearly north and south, has its southwestern terminus on Glacier bay about 5 miles from the end of the glacier. The eastern shore line rounds gradually into the bay without well marked headlands. The inlet gradually narrows as we approach the glacier, being about 1½ miles wide at its upper end. On each side are deposits of roughly stratified sands and gravels, covered with a thin layer of moraine debris. On the western side these deposits form a comparatively level plateau from 150 to 200 feet high, which extends about 4 miles south of the present ending of the glacier, and is about a mile wide. Its surface bears a number of shallow lakes, and here and there deep ravines mark the positions of former watercourses. The western subglacial stream has cut a gorge through this plateau and exposed the buried forest described by Professor Wright. See page 39. For 3/4 of its length the plateau ends on the water side in precipitous bluffs, below which there is a narrow beach, only covered by the highest tides. On the eastern side the bluffs only extend for a half mile or so. The upper surface of the deposit is not a plateau, but slopes gradually down to the bed of the glacial stream at the foot of the mountains. The stream empties into the inlet just below where the bluffs end. South of the stream the deposits slope gradually up from the beach to a height of about 400 feet against the mountain side. The inlet is quite deep. Professor Wright reports a sounding by Captain Hunter of 516 feet, about 1,300 yards south of the present position of the ice front. Captain Carroll last summer, 1890, found within 100 yards of the ice front a depth of 720 feet. This does not necessarily indicate that the inlet increases in depth as we approach the immediate neighborhood of the ice, for the earlier sounding may not have been taken in the deepest part of the channel. Section 4.